All right, so here's this extra video I was talking about for expanding binomials. First off, let's just do it the long way. So when we got x plus 3, the quantity to the fourth, that is saying x plus 3 times x plus 3 times x plus 3 times x plus 3. Okay, so when we do this, you'd have to multiply all the way through. So again, just multiplying those first two, you would get x squared plus 3x plus 3x plus 9. Okay, and then you still got the x plus 3 times x plus 3. Okay, simplifying that, you get x squared plus 6x plus 9. Now, that's what we got for x plus 3 times x plus 3. So those next two would be the same thing. And then you would have to multiply through again. So to get that, it would be x to the fourth plus 6x cubed plus 9x squared. That's going through with that term. Now distributing that 6x, you get plus 6x cubed plus 36x squared plus 54x. That's multiplying with the 6x, and then bringing that 9 through, plus 9x squared plus 54x plus 81. Then finally you would have to combine your like terms. So I got x to the fourth, and then I would need to find my cube terms to give me 12x cubed. And finally, then my x squared terms, which would give me 54 x squared. My x terms, my linear terms, 54, to give me 108. And then finally plus that 81. So that is one way you could do that. Now, the way I want to show you with this video is what we call binomial expansion. Okay, and with binomial expansion, we use something that is called Pascal's triangle. Okay, so the way they determine this triangle, okay, you start with the peak, which is 1, and then you get 2 more ones, and then from there, what you're going to do, okay, the outside's always 1, but then to get that next term, you add the 2 terms above it. Okay, so we consider this level 0, level 1, 2, 3. Now to get the level 3, add the 2 above, so 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, and we can keep going on forever and ever. Okay. Now that triangle is to the left. Okay, and again, we said the first level is that where it's just 1. The second level, first level is that 1, 1. Second level, 1, 2, 1. Third level, fourth level, fifth, sixth, seventh, and it can go on forever. Now, the way we use this triangle is to help us with expanding binomials. Okay, so whatever number you're taking to, so like in this case, it's to the fourth power. In that case, we are going to use the fourth level of Pascal's triangle. Okay, and those numbers, the way we use those numbers is we're going to use those as coefficients. Okay, so we got 1, 4, 6, 4, 1. So we got 1, and then we're going to take 2 terms. Okay, and those 2 terms are going to come from your binomial. Plus the 4 times those 2 terms again. 6, 2 terms again. 4, 2 terms again. And then 1. Okay, now from there, you're going to take the first term of the binomial, so that x, and that's going to go in the first parentheses on each of those. So x, x, x. And then the second term, the positive 3, okay, you need to incorporate the sign in there. So if it was negative 3, it would go negative 3 in there. But in this case, it's just positive 3. Okay, and then from there, okay, we start with the x's, and we're taking it to the 4th power, so the x is to the 4th, and then we go in descending order, 3, 2, 1, and 0. And then in the other way, you start with 0, and you go in ascending order, so 0, 1, 2, 3, 4, okay, and then from there, it's a matter of simplifying all of those, okay? So again, 1 times x to the 4th times 3 to the 0, which would be 1. Okay, so in that term, you get x to the 4th. When you simplify this one, that's going to be saying 4 times x cubed times 3, which will give us 12x cubed. And the next one, that's going to say 6 times x squared times 3 squared, which is 9. So 9 times 6, we get that 54x squared. And the next one, that's saying 4 times x times 3 cubed, so 3 times 3 times 3, which is 27, which will give us that 108. So plus 108x, and then finally, plus that 1 times 1, because x to the 0 is 1, times 3 to the 4th, which is that 81. Okay, so with this, it is a little complicated to start, okay, but once you see the pattern, it is actually quite easy. Now, it's not going to come easy unless you practice it, okay? So I'm actually going to go into the homework assignment for that. Again, this one is not required, but it will help you come test time, because this method is going to be a lot quicker come test time. So let's go ahead, let's do that x, let's do this one to the 5th power, okay? So when we use this, I think I got Pascal's, we're going to use row 5, okay, because we're taking it to the 5th power, so 1, 5, 10, 10, 5, 1. Okay, we're going to go to the bottom here, and it was, okay. So when we do this, we said 1, 5, 10. Okay, so just taking those numbers from that row of the triangle. I did 2 10s yet? Nope. 10, 5, 1. And again, you're going to take the 2x and the 1. So the 2x goes in the first parentheses. Okay, and then the second term of the binomial will go in the second parentheses. And then again, with the 2x, you start with whatever power you're taking it to and going descending order. And then start with 0 on the second term and go in ascending order. Okay, so then from there, it's a matter of simplifying those. So 2x to the 5th. So that's saying 2 to the 5th, x to the 5th. 2 to the 5th would be 32. So we got 31 times 32 x to the 5th times 1, which gives us just 32 x to the 5th, plus that 5 times 2x to the 4th, which will be 16x to the 4th, times 1, because 1 to any value, any power is 1. So 5 times 16, we're going to get 80. So plus 80x to the 4th, plus that 10 times 2x, that quantity cubed, so 8x cubed, times 1, which will give us plus 80x cubed, plus that 10 times 2x, the quantity squared, so 4x squared, times 1, which will give us 40x squared. and then plus 5 times 2x, because we're taking that to the 1, which will give us plus 10x. And then finally, the next part is saying 1 times 1 times 1, so plus 1. Okay, so if you were to get one like that on the test, binomial expansion is by far going to be the quickest, because otherwise you're going to have to do 2x plus 1 times 2x plus 1, 2x plus 1, 2x plus 1 times 2x plus 1. And I'll tell you this, it's going to get very messy. Okay? So real quick, just walking through it again, get the original setup there, and then right here you need to simplify each one. Okay? So I'm going through, and I'll tell you, it's a lot easier to simplify those one terms than to multiply that all out and then combine your like terms. It's going to get very messy if you go that route. Okay, so that is binomial expansion. Again, it's not required, but it's going to make your life easier come test time or anytime you get a question like this to expand binomials. All right, if you have questions, make sure you ask. Otherwise, have a good day.